Hello and welcome to my third video going over all of the physics that you need to know for the MCAT. In this video, we are going over how to think about motion in two directions and projectile motion problems. This is covering exactly what you need to know to be prepared to answer MCAT style questions. If you like this content or are just needing more help preparing for the MCAT, you can subscribe to my MCAT community, and there's a link to do that in my bio or in the description to this video. First, we're going to look at breaking down motion in two directions and make sure we're really good on the fact that the motion in the x direction does not affect the motion in the y direction, and the two can be treated completely independent of each other. Starting with this ball right here. This ball is moving 10 meters in the x direction and there's no other motion going on. Once it leaves the table, it's going to start to fall downwards, so we see that y velocity start to increase just because it's starting to fall. We are saying that the only force in this entire situation is gravity, and that just points straight down on the ball. If there are no forces moving on the ball in the x direction, so we're not pushing on the ball in that direction, and there's no air resistance in that direction, then the ball's motion in the x direction cannot change. And that's something we'll talk more about in the next video when we go over F equals ma. But if there are no forces in the x direction, then the ball's motion in the x direction cannot change. And since gravity is only vertical, like we see by that arrow, then it only affects the ball's vertical motion. So just like we said, the motion in the x direction can be treated independently of the motion in the y direction. As the ball continues to fall, notice that it still moves 10 meters in the x direction, no matter how far away from the box it is. This arrow here is showing that the ball's velocity in the y direction is increasing the entire time that it falls. And again, that is because of gravity. Now we're going to look at a projectile motion problem to see how this is applied. We have a car that's about to drive off a cliff, and right now it is moving 80 meters per second in the x direction. But once it falls off the cliff, there's no force acting on it in the x direction. And the only force that will be acting on it will be gravity in the y direction, so the force of gravity. That means that as this car falls down, it's going to be moving 80 meters per second in the x direction the entire time, but the velocity in the y direction will be increasing as it falls. To solve a problem like this, you have to use kinematic equations, and the way that I like to go about using kinematic equations is to first list out all of the variables that we're given. Let's first start with the x direction. Our initial velocity is equal to 80. We know that the velocity doesn't change, so that means that our final velocity is also 80. And we know that since the velocity doesn't change, the acceleration must be 0. And in the y direction, our initial velocity is 0 before it starts to fall. The acceleration due to gravity is always 10 meters per second squared. And because we're told that the cliff is 20 meters, we can say that delta d for distance is equal to 20. Anytime you're dealing with a problem where something is falling off of a surface, the first thing that you want to do is figure out how long does it take for that object to hit the ground. So what we're saying is how long does it take for this object to travel 20 meters in the y direction. So all we are focused on is the y direction right now. And we're trying to solve for time. Look at your kinematic equations and see which one has time and also has these other variables that I can plug in to find my missing value of t. The kinematic equation that you would want to use for this is delta d equals vi times t plus 1/2 acceleration times t squared. And then just plug in all of the variables that were given and solve for t. That gives us 20 is equal to 0 times t plus 1/2 times 10 t squared. That comes out to be 20 is equal to, this is all 0, so we ignore that, 5 times t squared. So then t squared is equal to 4, so t is equal to 2 seconds. Now what you do is you take this 2 seconds and you multiply it by the velocity in the x direction to figure out how far away from the cliff it is in the x direction once it hits the ground. So it takes 2 seconds for the car to hit the ground, but during that 2 seconds, it is traveling 80 meters per second in that x direction. So that gives us 160 meters from the cliff once it lands on the ground. Now let's do a projectile motion problem where an object is launched. Here we have a ball that is launched in the air and then it lands over here. And our goal is to figure out how far away did it land. This is going to be the first time that we have to use trig to figure out some of the components of our vector. You want to treat the diagonal vector, which is the velocity vector for this ball, as the hypotenuse of a right triangle. Here's the vertical side of that triangle and here is the horizontal side. And then it has that angle of 30 degrees right here. You need to have your unit circle memorized, and you can use the mnemonic 1975 and then add a 0 here. And that gives you the values for cosine of 0, 30, 45, 60, and 90. And then going backwards, that gives you the values for sine of 0, 30, 45, 60, and 90. The first thing you want to do is figure out what is your velocity in the y direction and what's your velocity in the x direction. For the x direction, you're going to do cosine of 30 is equal to adjacent over hypotenuse, so we will do x over 10. Now you have 10 cosine 30 is equal to that side. Cosine of 30 is 0.9, so you have to put a decimal point in front of the 9, 7, and 5. So we have 10 times 0.9, giving us a value of 9 for x. For the y direction, we do sine of 30 is equal to opposite over hypotenuse, which is y divided by 10. Sine of 30 is 0.5, so we end up with 10 times 0.5 for y, so y is equal to 5, giving this side a value of 5. And that is meters per second for each one of those. For these types of problems, what you want to do first is figure out how long does it take for this object to reach the peak of its arc. The way that you think about this is a ball that's traveling up with a velocity equal to that y component, which for this one is 5 meters per second. And we know that the acceleration is always down with a value of 10 meters per second squared, and since it's in the opposite direction of that 5 meters per second going upwards, we're going to say that it's negative 10 meters per second squared. To figure out how long it takes to get there, you can just logic through that or use the kinematic equation Vf equals Vi plus a times t. Once it's at the peak, the final velocity is going to be 0, the initial velocity is 5, the acceleration is negative 10, and we are solving for t. Negative 5 is equal to negative 10 times t, so t is equal to 0.5. So it takes half of a second for this object to reach the peak of its arc. A convenient thing that you need to know about these launch problems is that the time it takes to reach this height is the same time that it takes for it to fall back down to the original height that it started at. So since it took half a second to reach that peak, that means that the entire arc takes 1 second. So to figure out how far this ball traveled, all we do is take 1 second, since that's the entire time of this arc, and then multiply it by the velocity in the x direction, which we figured out to be 9 meters earlier. And 1 times 9 meters per second gives us 9 total meters.